All right, so we're going over Z-scores. Yesterday we talked about the normal distribution curve and how it looks like this. We talk about the mean and then those standard deviations to the right and the standard deviations to the left. So look at this problem just to review. You should have already checked the answers on the 3-page worksheet from yesterday. It says a normal distribution of data has a mean of 66. Normal distribution is important. Mean of 66, standard deviation of 11. Find the probability that random value x is less than 44. So let's look at this and figure out what it's going to be. Normal curve, here we go. Straight down the middle, this is where our mu, our mean, occurs. And we are told that the mean is 66 and standard deviation of 11. So one standard deviation to the right would be 77. 66 plus 11 is 77. One deviation to the left, remember this is positive standard deviation. This is one negative, and that's going to, that's not minus. It's minus 11, but it's going to give you 55. And then 2 standard deviations will be 88. 3 standard deviations will be 99. Negative 2 standard deviations would be 44. And go back 3 standard deviations and it would be 33. So we've got our mean here. We've got 1, 2, 3. We've got our 3. Now you got to remember from yesterday that we have this value here, which represents 68%. So I always put 34 and 34. And then you are given that this whole piece here represents 95%, which is going to be 13.5 and 13.5. And then from 33 to 99, that represents 99%, which means this is 2%, this is 2%. And over there in those extremes, you've got 0.5% and 0.5% over here, okay? Now, as long as you know those little numbers, you're good to go. It says, find the probability that the random value x is less than, that it's less than 44. Now, if you, let's look at this, okay? 44, well 44 happens right here, and we want to look to the left. So all I do at that point is I'm going to take 0.5 and I'm going to add 2, and I get 2.5% is less than 44 on my graph. And if I wanted to change that, let me see if I need to. I could have 2.5% or 0.025, okay? Now, if you look at the next part, it says what percentage is between 44 and 99. So now I'm looking at the value, the portion of that curve that is between 44 and 99. And that's from here to here and here to here. And once I have those lines drawn, folks, I'm usually pretty good because all I do from that point is I just add those values. And I'm going to take each of my little numbers, and I'm going to take from 44 to 99, I'm going to take 13.5 plus 34 plus 34 plus 13.5 plus 2. Now, this definitely shows you that I'm a tree person and not a forest person because I'm looking at every little tiny piece of that forest. All right? And when you add those up, you end up getting 97%. So what that means is that 97% of the data under, or 97% of the area under that normal curve is between the numbers 44 and 99. Now, I gave you a preview yesterday that said, and of course you review this or pause when you need to. Just hit pause. But I said yesterday that what's going to happen when I give you a number that's not on my normal curve? What are we going to do? So this is what we're going to do. We're going to look at this, and we're going to be happy. Right, y'all? Right, y'all?
Yeah.
See how happy we are? And we're going to talk about standardizing normal distribution, which is so much fun. And in your notes there, it says that the Z-score represents the number of standard deviations a given value, is away from the mean. So now, instead of our curve's going to look the same, but our numbers are going to be different. We'll have 0, 1, 2, 3, -1, -2, -3. Because if my number is not actually on the curve, I've got to standardize it. I've got to make it all look the same. So we're going to make our graph look like this with these values, -3, -2, -1, 0, 1, 2, and 3. Now, how do we find it? In order to find your Z-score, folks, you're going to have Z is equal to X minus mu over sigma. And it's your value, take away your mean, our value. Take away the mean or the average divided by the standard deviation. Typically, all of that information is given to you, but that's what all these letters mean, these Greek letters mean right here, okay? Is that right there. Hit pause if you need to. So, another typo, sorry about this. Find Z if X is 18, if mu is 22, and the standard deviation is 3.1. Fix that. Now, what we did in the past was we set up our curve, hallelujah. We had our value, our mean is 22, and our standard deviation is 3.1, so 25.1. If we step back and take 22 minus 3.1, folks, we get 18.9. Step back again and subtract 3.1 from 18.9, and we get 15.8. Now, that ought to make you kind of stop and scratch your head a little bit, because our X is going to be 18, and 18 is going to fall somewhere about right there on that curve. That's odd. So what do? This is when we convert to a Z-score, okay? So how do we find our Z-score? Remember, you take your X value, take away the mean, over or divided by the standard deviation, which is going to give you 18 minus 22 divided by 3.1. And remember, when you put this in your calculator, you need to use parentheses there. And then that gives you a value of approximately -1.29. Now, what do you need? How are we going to use this -1.29? This is when we are going to use our Z-score table. All right, now I gave that to you on Monday, and I said hang on to it, and we will look at it later, okay? And I want to show you this, if I can get it to open up. So pull out that Z-score table. Ain't that right, y'all?
Yeah.
See, they have theirs already out on their desk. So here's the Z-score table. All right, here we go. Our Z-score is -1.29. So you want to flip to the side that has negative numbers, and here it is. And it said -1.29. I'm going to say that 400 times. -1.29. If you look here, we've got -1.2 down here on the left side. I've got to get the 0.09 from up here. Here it is, okay, right here. You see my cursor moving. So in the last column for negative 1.29, I go across here, and I find that my z-score is 0.0985. 0.0985. 0.0985, because I'm going to forget it before I walk back up here. 0.0985. You use your table. Now pause and you guys help each other to find this value. Now, what does the number on the table mean? What does it mean? What does it mean? It means that the area under the curve, this is important, to the left of our z, which is negative 1.29, is 0.0985. It is a portion of the area. Under that curve. What does that mean? All right, let's look at it. So we have our curve. We have our mean, which is, oh, well, we're using z-scores, so it's 0, 1, 2, 3, negative 1, negative 2, negative 3. And we just found that our number was negative 1.29. So that's going to be, I don't know, somewhere about right there. So that means this portion to the left of our line at negative 1.29 is going to be approximately, if it's 0.0985, that percentage is 9.85%. That means that the portion under that curve is 9.85%. And what would be then the portion under the curve this way? How am I going to figure that out? Well, I'm going to take 100, and I'm going to take away 9.85%. And that's going to give me 90.15. All right, let's go back and make sure we've done what we needed to do. Said find Z. Did we find Z? Yep, we did right here. Find Z, and we found it to be negative 1.29. And that's all we had to do there. Okay? Now, I want you to go back and look at this. How do you know when to use a z-score? When this number that you're given, when this number right here is not on your curve, once you put your standard deviations, that's when you default, and you go to find that z-score. And we're going to have to standardize everything. Okay? Take a moment, just look at that. Now, how are we going to use this? We'll see what's next. It says consider the random variable x, which is a normal distribution with mean equal to 34 and standard deviation of 4. Compute the z-score of 41. Okay? So, it's telling you what to do. There is no thought to this. You have to find the z-score. So the z-score is equal to x minus mu over sigma. And we start putting in these values. The value that we're given says compute the z-score for 41. Well, that's our x right there. So x minus, the mean is 34. X minus, should be 41. 41 minus 34 over standard deviation of 4. All right, put parentheses around that, and you find your z-score to be 7 over 4, which is approximately 1.25. Okay, 1.75, 1.75. Can't read my writing. Now, what does that mean? This is on the formula sheet. folks. If you're looking at that graph, here's 0, here's 1, here's 2, here's my 1.75. If I had to find that z-score there, that means that that z-score is going to be to the left. Okay, whatever I find on that 1.75. All right, here I am at my negatives. Let's go to my positives. 1.74. It's not going to help me. 1.7 is here. 5 is here, so I'm going to get 0.9599 right there, 0.9599. Go back. That means from here at 1.75 to the left, this is 95.99% of the values for this graph, whatever those values could be. Hit pause, see if you have a question. Think about what we did. Think about what we're looking at. Just hit pause. Now we're looking at an application problem, folks, talking about a finance exam. And this is when we have to do two things. All right, we're looking at an exam that Peter took. That was a finance exam. And he got a grade of an 89. The mean for his class was 77, standard deviation of 15. So that's all about Peter. And then we talk about Jenna. She took her math test. She got an 84. But the mean for her class was 75 and the standard deviation of 5. So they're arguing on who did better. Because, you know, based on just the percentage grade, it looks like Peter did better, but did he? Okay? So if we're talking about two different people, we've got to standardize this since we're talking about two different tests. So we've got to find the z-score. Remember, it's x minus mu over standard deviation. All right, here we go. So let's talk about Peter. What is his information? The value, his score was an 89. The mean for his class was a what, folks? Mean for Peter's class is a what? The mean average, the average for Peter's class is a, that's right, it's a 77, good. And then the standard deviation says it was 15. Put that in your calculator, and you should get approximate, well, you should get straight up 0.8. All right? And then Jenna, I'm going to take, and we're going to have 84, because she got 84 on her exam. We're taking away the mean, which is 75, and the standard deviation of 5. And when you figure that, her z-score ends up being 1.8. Now, I want you to think about this. Just looking at their z-scores, which one do you think you did better? Just looking at z-scores. Not even putting anything on a graph. Okay, 0, 1, 2, 3. -1, -2, -3. All right, I'm going to plot 0.8 in blue, which should be about right here. 0.8, that's Peter. And then 1.8, which is Jenna. She's right here, okay? I don't know about you, but I can look at that and tell who did better because we're comparing two separate tests, okay? So I'm thinking that Jenna probably did better, but let's figure out why, okay? If we go back to our table, our z-score table, 0.8. Folks, 0.8 is here, and we have 0 or 0.00. So the z-score for Peter is 0.7881. 0.7881. If you go back and look, 1.8 for Jenna, I'm going to go to 1.8 and it's 0.9641. 0.9641. So what does that mean? That means, and I used to hear this when I was little, and I didn't understand what it meant, but what this means is the area to the left of this is approximately 78.81%. The area to the left of where Jenna scored, it's going to be much more because she's farther over, and it ends up being 96.41%. What that means is that Peter, let me put that in blue, Peter scored higher than 78.81% of his classmates. Although it was two separate tests, we still can compare how they did. Jenna scored higher than how many in her class? Approximately 96.41% of her class. So Jenna's got it going on. Ha ha, Jenna. Peter, you suck. Go back and study. Okay? Think about that. Hit pause. All right, so you've discussed about how the girls score better than the boys, right?
Yeah.
Ha ha ha. Based on that last example, that was the case. Here you go. This is a bad-looking normal distribution curve. What does this graph mean? All right, what if I give you this graph and look, this is horrible. Let's try this again. That's a little better. Boom. What if I gave you this picture, this graph, and it had that the Z-score was 1.02? What would you need to do? What does this mean? It means that you'll go to your Z-score table and you'll look at 1.02. Here's 1.0. Here's 0.02, so 8461. What does that mean? That 84.61% score lower. How many people this way is 84.61%? How many score higher? How would I figure that out? Would I take 100 minus 84.61? Yeah. That's right. And it would be about 15.59. Is that what you got? Excellent. Very good. Good job. Questions? Awesome. Hit pause and discuss if you need to. Here we go. Look at example 5. It says the ages of subscribers to this newspaper are normally distributed. That's important. With a mean of 36 years and standard deviation of 5, what's the percentage of subscribers that are more than 37 years of age? What's the percentage of subscribers between 34 and 37 years of age? We've got to do two different things here. Let's see if we can put this on our normal curve, okay? Our mean was 36, and it said it had a standard deviation of 5. So 36 plus 5 is 41, 46, 51. 36 minus 5 is 31, 26, 21. Right on? All right, let's look at it. 37 years of age. That's the first. What's the percentage of subscribers that are more than 37? Where does 37 fall? It falls right here. So if it's not on my numbers for my normal distribution curve, what do? I have to go to Z-scores. Okay, and standard. I got to standardize my curve. All right, so now, here we go. This is when I go with 0, 1, 2, 3, -1, -2, -3. All right, here we go. Let's look at this. I've got to find the z-score for 37. I got to also find the z-score for 34 because both of those numbers are needed. So here we go. So I want to find my z for 34, which is 34 minus, the mean was 36. I'm getting that straight from my graph. Standard deviation was 5. That was given, but I also know that 36 plus 5 was 41. That gives you -2/5, which is -0.4. So my z-score for my 34-year-old was -0.4, I think. Yep, that's right. Then the z-score for my 37-year-old, 37 minus my mean over my standard deviation is 1/5, which is 0.2. This is exciting stuff. Woo! Isn't it? Isn't it exciting? So, I know. So here we go. Yep, that's right. Go to your z-score table. -0.4. I'm on the wrong side. Go to the negative. -0.4. Boom, right there. It's 0.3446. I want to go to 0.2. So find my value when it's 0.2. 0.5793. 0.5793. Now, what do I do with that? Here's what I do with that. Here's what I do with that. Here's what I do. I'm going to go back. And I'm going to draw another curve right here. Okay? And I want you to think about this. Here's 0. Here's 1. Here's 2. Here's 3. Here's -1. -2. -3. Here we go. If my z-score for the 34-year-old was -0.4, and my z-score for the 37-year-old is 0.2, I got to do two different things. Go back to the problem. It says, what's the percentage of subscribers that are more than 37 years old? Well, folks, if this is over here for my 37-year-old, and at 0.2, this portion of the graph is 57.93. That's below it. Let me see, we wanted to find out how many were older than, how many are more than 37 years old. So I'm going to take 100 minus 57.93, and that's going to give me 42.07% are more than, older than 37 years old. That's answering that first question, right? That's right. Yep, that's exactly right. And now we're going to find the percentage between 34 and 37. Sorry, I was shushing a bug away from me. So I've got to find this portion, that region in between -0.4 and 0.2. So how do I do that? Well, I found both of my numbers. I'm going to take 0.5793, and I'm going to take away 0.3446. If I take away my big number and take the little number away from it, then that will give me what's left over there in the middle. And when I figure this out, when I calculate this, it gives me 0.2347, which means that the portion in the middle, the portion that represents the subscribers between 34 and 37 is 23.47%. So 23.47% of subscribers are between 34 and 37 years of age. That's the second portion to that problem, okay? Questions on that? Think about what we did. We had to find the big piece. We had to find the big number. Had to find the little number. We subtract them, and we find out what's in the middle here, okay? Pause and look at that. Think about it for just a few minutes. Look at last example, I think. So we're talking about the heights of adult men. I think this is probably spot on. Very interesting. It says the heights of adult men are normally distributed and says that the average is 69 inches. Okay? Now, standard deviation of 3. That means 72, 75, 78. That is 1 standard deviation, 2 standard deviations, 3 standard deviations. Go the other way. We have 69 minus 3, which is 66. 2 standard deviations back would be 63. 3 standard deviations back from that would be 60. And these all represent inches, folks. Okay? It says find the Z-score for the man that's 65 inches tall, which is going to be right there. That means he is 5'5". Short little fella. Wow. All right, here we go. Z-score. It says find the Z-score. So here we go. The Z-score is equal to 65 minus the mean, which is what? That's right, 69. Divided by the standard deviation, that is, yes, that is correct, 3. Very good. Negative 4 divided by 3, which is approximately negative 1.33, because it is 3 repeating. All right, now think about your Z-score table. It's to the hundredth, so this has to be the hundredth. So what you need to think about, did we find the Z-score? Yes, we found the Z-score. But what if I were to take this a step farther and say, that's our answer for the first part, 65-inch tall man, his Z-score is negative 1.33. Here's the second part to this problem. Find the Z-score for the man 73 inches tall. All right, so same thing. Find the Z-score, which is 73 minus. The mean was 69. Standard deviation was 3, I think. Yep. And that gives us Z is approximately 1.33. Repeating, okay? Now, let's think about what we're looking at. What percentage, here's the third part. We found this part. Last piece of the puzzle. What percentage of men are between 65 inches and 73 inches tall? All right, so we totally have to go to our Z table, and we've got to find both of these decimal numbers, okay? So let's go back to our Z table and find the Z-score for 1.33, which is here, 9082. This is 9082. Let's look at the value for that negative term. Must be the other way. All right, 1.33, negative 1.33. Here we are. And I think it's 918. Yep, 918, that's right. 918, right here. All right, what am I going to do with those two numbers? I'm going to subtract them just like I did before. 0.9082, which is our 73-inch tall man. We're going to take away 0.0918, which is our 65-inch tall man. And we're going to find out how many men are between 5'5" and 6'1". And we get approximately 81.64% of the men are between 73 inches and 65 inches. What do you think about that? I'd say it's probably true. Questions? Awesome. Worksheets. Have fun. I will see you tomorrow. And we'll go over permutations and combinations, and we'll review for our SOL on Thursday, Friday, and Monday. Get you some rest. Bye.